Welcome to the Sleepy Physicist. Hello and welcome to the Sleepy Physicist. I'm truly delighted you've joined me. Perhaps you're cozying up under a favorite blanket, or maybe one ear is listening while the other softly rests on a pillow. The room might be dim, the air still, and your thoughts are already beginning to quiet down. No matter where you are, you've found the perfect spot for this journey, a voyage not just through space, but into something gentler, something more enigmatic, something immense. Tonight, we'll start with a unique kind of darkness. This isn't just the absence of light, but the presence of something profound, something that defies the universe's usual laws, pulling at time and consuming entire beams of light. We're going to explore a black hole. I'll do my best to keep this experience profoundly calming. However, I should mention that the universe can sometimes be a bit too fascinating. If you find your eyes staying open a little longer due to sheer wonder, I certainly won't blame you. Still, I hope sleep ultimately finds you, and if you're finding comfort in this tranquil moment, I'd be incredibly grateful if you'd quietly like this video or even subscribe. It genuinely helps other wary minds worldwide discover this space. You can also send a super thanks if you wish to support the channel. Your contribution means more than you know. So, let's drift together now. We'll move far from Earth's rotation, away from the day's climber, into a peaceful darkness that isn't empty but brimming with mystery. The birth of a black hole. Our journey begins with a star. Not the five-pointed kind we sketch, or the shimmering dots sprinkled across the night sky, but a real star, blazing, colossal, and ancient. It's lived a long, magnificent existence, yet like everything else, it too must eventually end. Deep within a star's heart, its core, atoms are compressed by extreme heat and pressure. This process, fusion, is precisely what enables stars to shine. Hydrogen transforms into helium, and from this change, light is born. That light pushes outward, counteracting gravity's inward pull, establishing a balance that keeps the star intact. But with time, this balance weakens. The star's fuel depletes, much like a candle burned down to its wick. There's nothing left to sustain the steady flame. The outward pressure diminishes, and gravity, quiet and persistent, takes over. And when gravity faces no opposition, it does what it's always inclined to do: it pulls. It draws everything inward. The star collapses in on itself, compressing tighter and tighter until its core is crushed into something so unbelievably dense and heavy that it becomes a black hole. Here's the peculiar part: this collapse doesn't conclude with a sudden bang in its final moments, not in the dramatic way we might expect. Instead, it happens silently. A gentle implosion into quiet. The light that once radiated from the star cannot escape. It's captured, held, pulled inward by gravity's unseen grasp. You might envision it like a bell that ceases to ring, yet whose silence resonates more profoundly than any sound. The light vanishes, the star vanishes, yet something remains. What remains is gravity so intensely concentrated that space itself bends towards it, like a sheet pulled down at its center. Imagine a deep, dark well in the cosmos's fabric, a well so profound that even time leans into it. This is a black hole, a region in space where the laws of physics grow quiet, where time itself loses its linear path. Understanding the unseen, it's easy to perceive a black hole as some sort of terrifying entity or a monstrous void. But tonight, let's consider it differently, not as a beast, but as a question, a mystery so deep the universe has enveloped it in silence. If you were to float near a black hole, not too close, but close enough, you wouldn't see an empty space. Instead, you'd observe the surrounding space shimmering with light, swirling with the last vestiges of matter being drawn in. Material spirals inward like leaves caught in a slow, unending whirlpool. The black hole itself remains invisible, not because it conceals itself, but because it permits no light to reveal its presence. It doesn't glow or reflect, it simply is. There's no solid surface or wall to encounter, just an edge known as the event horizon. This is a boundary where, once crossed, nothing returns. Not because it's blocked, but because the path back out simply ceases to exist. Even light, the fastest known entity, finds no escape. Yet, from a great distance, you might not notice anything out of the ordinary. A black hole could reside quietly at the center of a galaxy, unseen yet immense, subtly influencing the movement of stars around it. Gravity isn't loud, it doesn't shout. It whispers and the universe listens. Black holes don't roam space like predators, they aren't hungry or in pursuit. They are still powerful and peculiar. And the most peculiar aspect is that they are born from light, from stars that once warmed planets and illuminated skies. In their final act, these stars give the universe something new, not light, but gravity shaped into shadow. There's a strange comfort in realizing that even endings can birth something mysterious, that in the stillness after collapse, something silent, massive, and beautifully strange endures. Tonight, you're floating near one. You're not falling in just yet, merely drifting nearby, observing the bending light, the curving stars, and how the night stretches a bit longer than it should. You are close enough to sense the peculiarity, close enough to know that this darkness isn't empty. It's full of mass, full of wonder, full of questions. And perhaps one of the quietest questions of all is this: what occurs at the edge where light hesitates and time becomes stretched thin? In our next segment, we'll approach that edge, the subtle boundary from which nothing escapes the event horizon. The star's transformation. The star is ancient, having shone for billions of years. Its light has traveled across vast distances, warming distant worlds and shaping galaxies with its quiet, burning essence. It has experienced fusion, balance, and brilliance. But, like all things, even stars must ultimately cease to exist. You're observing from a safe distance. The light it once emitted now softened, like the final embers of a fire before it goes out. It's no longer the steady, blazing engine it once was. Deep within its core, fuel is depleting. The hydrogen it once fused into helium has been consumed. The star begins to transform, first swelling, growing larger and redder, like a final exhale. In this phase, it becomes a red giant. Its outer layers gently drift outward, delicate and slow, like a silk scarf unfurling in the wind. The light it emits is now warmer, tinged with age, and deep inside, gravity begins to stir once more. Without the intense outward pressure from fusion, gravity steadily asserts itself, not suddenly or violently, but with quiet certainty. It pulls inward with patient strength, drawing the star tighter and tighter into itself. Unable to resist, the star begins to collapse. You might anticipate a sound, a roar, an explosion, but space is silent. The collapse happens quietly, a whisper folding inward. The core shrinks, compresses, and densifies beyond anything the mind can conceive. Matter, once spread out as gas and flame, transforms into something new. It crosses a threshold where atoms no longer behave as they used to. They can't. There's no space left. And so the collapse continues, not stopping at the size of a stone or a coin, or any solid form you've ever known. It keeps going, becoming deeper and denser until the core turns into a singularity, a point with no size but immense mass. This is a place where the laws of physics seem to break down, where gravity becomes not just a force but a final destination. This is the birth of a black hole. There's no grand ceremony or crowning, just the quiet retreat of light, the gentle tug of space curving inward, and the disappearance of time's steady rhythm. Where the star once shone, now there is something darker, heavier, more mysterious. A gravitational memory, however. The story doesn't end with the collapse, it begins anew, differently. A black hole isn't merely a location, it's a presence. It shapes the surrounding space, influences the paths of stars, and tugs at time as if it were a thread. Where it resides, space-time bends like fabric under a heavy weight. Imagine placing a marble on a soft sheet. It creates a small indentation. Place a bowling ball, and the indentation deepens. In this analogy, a black hole isn't a ball, it's a deep, invisible funnel, not because it punctures the fabric, but because it stretches it to its absolute limit. The gravity here is so potent that even light, traveling at the fastest speed we know, cannot escape. Once it reaches a certain distance, the event horizon, it cannot return. Not because it's caught in a trap, but because the very nature of space and time has fundamentally changed past that point. Time near a black hole behaves differently. If you were close to one, your seconds would stretch out compared to someone far away. You wouldn't perceive this yourself. Your heartbeat would still be steady. But to others, you would appear to slow down. Time becomes relative, like a story told in various voices. All of this occurs because a star could no longer sustain itself, because gravity, quiet and relentless, finally prevailed. You might view this as an ending, but nature rarely writes final chapters. More often it interweaves stories, nesting them like dreams within dreams. The star, in its surrender, gave birth to something more enduring than its light, a gravitational memory etched into the universe. There's a peculiar peace in knowing that even in collapse, something remains, in sensing that the universe doesn't waste but transforms, in realizing that a black hole isn't destruction, but a different form of existence. And so, we float near this newly formed black hole where the star once thrived. We feel no heat now, no flare, just the quiet weight of what was. You envision all the atoms once vibrant with light now compressed into silence. You imagine a place where falling never ceases. You contemplate what it means to vanish yet still exist. From this location, space curves, stars orbit, and light bends. It's as if the black hole is still narrating a story, just in a language we're still learning to comprehend. The universe is filled with stars that couldn't hold on, yet they became something else, markers of time, of mass, of mystery. Places where the familiar world yields to the unknown, inviting not fear but wonder. And as you drift here, you feel that wonder like a gentle pulse. The black hole isn't moving or beckoning, but it is there, a presence so powerful that space cannot ignore it, a silence so profound that time slows down to listen. And so, you listen too. You listen to the quiet surrounding it and begin to ponder where this boundary lies, this soft edge between the outside and the inside, where light pauses, where escape becomes return, where the universe subtly draws a line in space. In our next section, we'll approach that line, the boundary that truly defines a black hole, the place of no return, the event horizon. The fabric of space-time. You now drift in silence. It's not moving, yet it's in constant motion. There's no sound, no ground beneath you. Only the vastness, only the quiet breath of the cosmos stretching in every direction. You're suspended in something imperceptible, not air, not space precisely, but something deeper. This is space-time, not two distinct entities, space here and time there, but a single, continuous fabric woven together like threads in a silent tapestry. It's not something you see, it's something you feel, much like how a planet curves a comet's path, or how your weight gently presses against your bed as you lie down. You might conceive of space-time as a vast, soft sheet spread beneath everything that exists. Planets, stars, black holes, they all rest upon it, pressing into it. And by pressing, they leave an imprint, a dent, a warp. The more massive an object, the deeper it presses. It's like pressing your hand into sand and seeing its shape remain after you lift it. Earth creates a gentle impression. The sun presses more deeply, and a black hole presses so profoundly that the fabric doesn't just dip. It folds in on itself. This is gravity, not a force pulling from a distance, but a curve, a bend in the road that things naturally follow. When you drop a stone into a stream, it sinks, not because it's being pulled, but because the stream's shape guides it downward. Similarly, gravity bends the paths of things, not by grabbing, but by inviting motion to follow these curves. You're floating in this fabric now, not above or beneath it, but integrated within it. Every passing second is a journey across this fabric. Every breath you take is a tiny ripple in time's thread. Even light, which travels in straight lines across emptiness, cannot disregard these curves. Near a star, a black hole, or even our Earth, its path bends ever so slightly, just enough to reveal that the straightest line is only straight because of the fabric it's drawn upon. In your mind's eye, picture a marble on a trampoline. Observe how it rolls when you place a heavier ball in the center. The heavier the ball, the deeper the trampoline sags. The marble rolls inward, not out of desire, but because the fabric has changed. Now imagine that trampoline extended into 4 dimensions, 3 of space as length, width, height, and 1 of time. That's space-time. And when something massive presses into it, time bends too. You might not perceive it in your daily life, but time isn't uniform everywhere. It doesn't tick the same for everyone. A clock on a mountain runs ever so slightly faster than one at sea level. Not because it's faulty, but because gravity is weaker the farther you are from Earth's center. Time flows differently depending on your location in the universe. This isn't just a theory, it's real and measurable. It's why GPS satellites in orbit must account for time dilation, as their clocks run faster than those on Earth. Now imagine what that means near a black hole, where gravity is so intense, the dip in space-time so profound, that time itself slows dramatically. From a distance, someone observing you fall toward a black hole would see you slow down, each second stretching, each movement lagging, until, to them, you never quite reach the edge. But for you, within your own experience, time feels normal. You breathe, you move, you fall. It's only when you glance outward, toward the stars behind you, that you notice how strange everything has become. Because space-time isn't just a stage, it's an actor as well. It shapes how things move, but it's also shaped in return. Einstein's theory of general relativity tells us this, that mass and energy bend space-time, and that bend is what we perceive as gravity. It's not that Earth pulls you downward. It's that the space around Earth curves, and your body follows the shape of that curve. Like a river following the land it flows through, or a leaf drifting on a pond's surface, you are always tracing the shape of the fabric beneath you. Even now, as you lie still, your body gently presses into Earth's curve. You are part of space-time, not separate from it. You're not just in the universe is in you. As you drift in thought, imagine tracing the thread of time backward, each second gently unraveling behind you. Past stars, past dust, past the glow of galaxies, back to the moment when space-time itself was born. Because space-time hasn't always existed, It had a beginning at the event we call the Big Bang. Before that, we don't yet know what existed, or if the word before even holds meaning when time itself hadn't yet commenced. But from that beginning, the fabric expanded, and it continues to expand now, stretching, thinning, carrying galaxies apart like dots on an inflating balloon. You are within that stretch, a minuscule point on that balloon, kept in motion by the fabric's shape beneath you. Black holes, then, are not literal holes in the fabric. They are places where the fabric dips so deeply it folds in on itself. And in that fold, time and space become something we still don't fully comprehend, but we can sense it in thought, in story, and in dreams. And tonight, as you drift deeper into sleep, you are resting in that fabric, cradled by it, a part of it. The stars press their weight into it, and so do you, softly, quietly always. And somewhere out there, a black hole curves space-time with such intensity that even light hesitates. What happens, you wonder, when something crosses that edge? When it slips past the horizon where time bends beyond return. In our next section, we'll journey there, to the soft, invisible boundary that marks the beginning of eternal falling. The event horizon. The event horizon, the point of no return. There's a line out here, not one you can see, feel, or even touch, yet it holds more significance than most. It doesn't announce itself or glow, it simply waits, quiet and patient, like the moment before drifting off to sleep. You're hovering near it now, gently at the edge of a black hole. This isn't a dangerous place for your mind to explore, it's a place of stillness, of slow breaths, of contemplation. This line is called the event horizon. It's not composed of anything tangible, no wall, no fence, no light. Yet it is undeniably real, a boundary between what can be observed and what can never return. Outside this line, the universe persists, time moves forward, space expands, and light travels freely. But once something crosses the event horizon, be it a light beam, a piece of matter, or even a faint whisper of radiation, it cannot come back. Not because it's trapped in a prison, but because the very shape of space-time beyond that point curves inward so sharply that all paths lead deeper inside. Imagine descending a hill that steepens with every step. At some point, the incline becomes so extreme that turning back is no longer feasible. Even if you try, the ground beneath your feet propels you forward. This is what transpires at the event horizon. You won't notice a change upon crossing it. There's no sensation, no jolt. From your perspective, everything seems normal. But to an observer watching from afar, you would appear to slow down, to pause precisely at the edge. Your image would freeze, your light would stretch, redden, and then fade. To them, it's as if you never fully fall in, as if you linger on the horizon indefinitely, caught in a perpetual loop of almost. But you keep going. This peculiar difference in perception is part of the magic of general relativity. Time itself bends and distorts here. Outside, it moves swiftly. Inside, it flows differently, curled inward, drawn toward the center. Even light, the universe's swiftest traveler, finds no outward path once it crosses this line. It cannot loop back, it cannot transmit a message. It becomes part of the silence. And so, the event horizon marks a quiet truth. What occurs beyond this point belongs exclusively to the black hole. That's why it's called a horizon, not because it's distant, but because it conceals what lies beyond. Much like the ocean meeting the sky, it's not an end, but simply where sight fades. Yet, this line defines the black hole, not the singularity within, but this horizon surrounding it. This is where the mystery truly begins. A black hole's size, how we measure it, is determined by this invisible shell, the perfectly spherical surface dictated by its mass. The greater the mass, the larger the horizon. If Earth were to shrink into a black hole, its event horizon would be less than an inch wide. The entire planet's mass compressed into a space smaller than a coin. Imagine that. Everything you've ever known contained within a breath of shadow. If our sun collapsed, its horizon would be just under 2 miles across. However, we observe black holes far larger, millions, even billions of times more massive than our sun. Their horizons span for hours across the sky at the speed of light. Still, even at these cosmic scales, the line remains delicate. Nothing truly touches it, but everything that passes it changes forever. Now you hover near it, not falling, just observing, watching how space bends, how starlight curves near this border and skims away like skipping stones on water. You imagine reaching out, but there's nothing to feel. You imagine shouting, but no sound would pass. What crosses this line departs from the map. It's still part of the universe, but no longer part of the story we can follow. Yet, something peculiar still happens here. At the event horizon, quantum fields tremble, particles flicker in and out of existence. Vacuum fluctuations, tiny fleeting dances, occur at the edge. Sometimes one of these particles escapes, while its twin falls in. From this process, a trickle of radiation begins. Hawking radiation, as it's known, whisper from the horizon itself, suggesting that even black holes may not last forever. But for now, the horizon is quiet. It waits, it listens, it defines, and you drift here beside it, resting on the rim of the unknowable. The universe stretches out behind you, full of galaxies and light. Ahead, only silence and curved time. And as you rest at this border without a wall, you sense something else stirring nearby. A presence, not of one black hole, but of two. Far in the distance, another darkness awakens, and it's moving towards this one. In our next section, you'll hear the beginning of a slow and silent ballad, a tale of two black holes. The gravitational dance. There's a kind of gravity you've always known, the force that keeps your body grounded to your bed, that makes an apple fall, a river flow downhill, the constant hum beneath your every step. But out here, gravity is different. It's not so much a pull as an invitation, a shaping of the path all things follow. It doesn't drag, it persuades. And once you begin to move towards it, the curve only deepens. Now imagine standing on a gentle, rolling, inviting hill, not a steep one. At first, it's easy to resist the slope, but take one step, then another, and soon you're moving. Not because you're forced, but because the hill dictates the direction. This is what gravity feels like near a black hole. It isn't sudden, it doesn't seize you. It cradles. It murmurs quietly to everything around it, come closer. Come closer still. Even light, that ancient traveler, hears this call. And though light has no mass or weight, its path is still shaped by the bend in space-time. The deeper the curve, the more the light tilts inward. Near a black hole like an orbit, it's caught in a perfect balance between moving forward and falling. This is called a photon sphere, a glowing halo that circles the horizon, never touching, never escaping. Only at this precise distance can light remain. Further in, it vanishes, further out, it flies free. You envision yourself within that ring, circling endlessly, perpetually near the beginning. Time here is strange. You advance yet always stay close to the starting point. Gravity in this place isn't fierce, it's soft, patient, inevitable. It doesn't command, it simply waits. You might recall how gravity influenced your life on Earth, how raindrops fell on windows, how leaves gracefully descended in autumn, how the moon drew the oceans into tides. Now, magnify that feeling by 1,000, by 1,000,000, until the very fabric of space-time seems to lean inward. This isn't Earth's gravity, this is gravity that curves time, that traps light, that creates a density so profound that not even energy can escape it. Yet, it doesn't feel violent. It feels like surrender, like closing your eyes at the end of a long day, like letting go. That's why some physicists refer to black holes as the most perfect objects in the universe. They are defined by only a few characteristics: mass, spin, and charge. No irregularities, no blemishes, no trace of the matter that fell in, only the memory of its weight. You can't tell what a black hole was originally made of, whether it consumed stars, dust, or light. Once inside, all becomes undifferentiated. Only the surface, the event horizon, communicates with the outside world. This uniformity feels strangely peaceful, like a final resting place for complexity, a gentle conclusion. Yet, black holes don't always remain still. Sometimes they move, sometimes they drift, and sometimes they discover each other. Far from your current position, another black hole journeys across space-time. Born from a different star, shaped by a different past, it has traversed the galaxy for a long time, and now it is approaching, not swiftly, but with the slow certainty of tides meeting on a quiet shore. Their paths have curved towards each other as if space itself has decided they belong together. They begin to sense each other's presence. Their horizons aren't touching yet, but the fabric between them begins to tremble. Gravity doesn't reach out like arms, it warps the field beneath, and the two black holes start to spiral. This isn't a collision, it's a dance. Each slowly circles the other at first, sending ripples outward into space-time. These waves are so gentle they pass through you now without a sound, without a feeling. These waves are called gravitational waves. They don't carry light, they carry movement. They ripple not through air, but through the very essence of space itself. Each pulse is a whisper from gravity's deepest reaches. As the black holes spiral closer, the dance accelerates. The waves intensify, not in volume but in power. The fabric stretches, flexes, and then releases. It's as though the universe is listening and gently acknowledging as two immense silences prepare to merge. But before they do, before their horizons touch, there's still time to float here, to feel the gentle pull that shapes the cosmos. Gravity doesn't need to be understood to be felt. It's why stars cluster, why planets orbit, why your body feels grounded now, safe and still. It's not a trap, it's not a force to be feared, it's a rhythm. And in the universe's deepest, darkest places, that rhythm becomes a hum. Low, constant, soft. You can't hear it, but you can imagine it, a kind of music composed not of notes but of curves and time. A music the black holes now dance to, and you, quiet in the night, drift closer with them. In our next section, we will track the progression of this dance as the two black holes spiral inward, step by step, towards their final embrace. Seeing the unseeable, you float in darkness now, but not alone. Beside you are instruments, lenses of thought, of technology, of patient curiosity. Telescopes aim not at stars, but at the spaces between them, cameras that don't capture light, but trace its absence. Because how do you perceive something that doesn't shine? This is the paradox of the black hole, a presence rendered invisible by its very nature. It emits no light, no heat, no sound. It is pure silence etched into space-time. And yet we have seen one, not directly, as we see stars or moons or mountains, but through a different form of sight, one that listens to echoes, observes how light bends, and follows the swirl of matter falling inward. It's akin to watching a curtain ripple in the wind and knowing the breeze is present, even though you cannot see it. The black hole itself doesn't reveal its form, but everything around it does. You begin to grasp this as you drift closer to one, a massive black hole at the heart of a distant galaxy. Not merely a traveler, but an anchor, not just hidden, but central. Surrounding it is a disk of glowing gas, spinning at nearly the speed of light. This is the accretion disk, a ring of material spiraling inward, heated by friction and pressure to temperatures that cause it to shine brighter than stars. Here, matter races in circles, caught between falling in and being flung outward. Each particle struggles against gravity and heat. Each photon emitted from the gas recounts this struggle. You can't see the black hole, but you can see this glowing ring, this halo of desperation. It's not peaceful, it's chaotic. Yet, from a distance, it forms a simple shape, a glowing ring with a shadow at its center. The shadow isn't the black hole itself. It's the absence of light from the space within the event horizon. And that shadow we have captured. In 2019, astronomers unveiled the first image of a black hole, or rather, its silhouette. The dark imprint left against glowing matter in a galaxy 55 million light-years away. This was the culmination of years of work and a telescope the size of Earth. The Event Horizon Telescope, a global network of radio observatories collaborating as one. They didn't take a photograph like you'd take a selfie. They gathered data, streams upon streams of radio waves arriving from deep space, mapped and assembled like a puzzle made of whispers. And from those whispers a shape emerged. A ring of fire, a deep dark center, not perfectly circular, but very close, a shadow edged in golden light. Seeing it was like glimpsing a mountain's silhouette through morning mist, a reminder that even the most elusive things can leave their marks. The image resonated deeply worldwide, not with fear or isolation, but with a quiet certainty that the theories were correct, that the invisible could be known. You see, Einstein predicted this, the shape, the shadow, the bending of light. General relativity told us what a black hole should look like. And now, there it was, real, confirmed, waiting. This is the beauty of science, not just in discovering the unknown, but in affirming that the universe behaves with elegance, even at its most extreme. You imagine light bending around the black holes, some pulled inward, some flung outward, some orbiting repeatedly before escaping. The image we see is shaped by that bending. The ring appears brighter on one side, a sign of light racing towards us, while the other side recedes. This asymmetry speaks to the motion of matter, the swirl of the disk, the immense speed and heat involved, and all of it created by something that emits no light of its own. To see the unseeable, we don't need sharper vision, we need patience. We need imagination. We need to trust the shapes left behind. Sometimes you realize the best way to comprehend something is not to examine what it is, but to observe how it influences everything else. The way a tree leans tells you the wind's direction. The way stars orbit tells you where mass is concealed. The way matter glows and vanishes tells you there's more than light alone can reveal. You dwell on that thought that absence can be rich with meaning. A black hole, invisible at its core, still narrates its story through motion, through light, through time. You don't need to fall into one to understand it, you only need to observe the world it shapes. And so, you float, feeling the gravity of something you cannot see, knowing it exists not by its presence but by its influence. There is comfort in that too. Not all truths need to be visible. Some are felt, some are known. Some are depicted in light's retreat. You now open your mind's eye not to see the black hole itself, but to perceive how time behaves near it, how seconds stretch, how motion slows, how falling becomes eternal. In our next section, we'll approach this concept more closely and feel time itself begin to shift and stretch near the edge of the unknowable. The shifting sands of time is something you carry without conscious thought. It ticks behind your eyes, settling into rhythms. Your breath, your heartbeat, your thoughts. On Earth, time flows steadily, gently held by gravity's familiar embrace. A minute feels like a minute. The sky changes, the clock advances, and life progresses in waves. But here, near a black hole, time transforms into something else. Not broken, just different, bent, curved, slowed. You are still near the event horizon, hovering just outside the point of no return. From this vantage point, time doesn't disappear, it deepens like a slow river thickening as it approaches a tranquil pool. Time begins to drag, not in a painful way but in a gentle, heavy manner, much like sleep itself. Imagine holding a clock in your hands. You watch its second hand move tick, tick, tick. Now, imagine someone far from the black hole in open space, observing your clock through a telescope. To them, the ticks would slow down. They would stretch, each one longer than the last. From their perspective, your time would linger, slowed by the gravity pulling you inward. This is not just a theory.